Today we're talking about graphing linear inequalities in two variables. So a linear equality in two variables is an inequality written in the form ax plus by is less than c, ax plus by is greater than c, ax plus by is less than or equal to c, or ax plus by is greater than or equal to c, where a, b, and c are real numbers. So an example of a linear equality in two variables would be x plus y is less than or equal to -6. In this case, my a and my b are represented by the coefficients 1. A solution of a linear inequality in two variables is an ordered pair that makes the inequality true. So here I have a solution for this inequality, -4, -4. If I put in -4 for both x and y, I get a total of -8. And -8 is less than or equal to -6, so it's true. So -4, -4 is a solution for this linear inequality in two variables. The graph of a linear inequality shows all of the solutions of the inequality that are on the coordinate plane. So in this case, here is my line, x plus y is less than or equal to -6, and all of my solutions are below this line. So everything here is shaded. We call this a half plane. The coordinate plane's been broken into two different regions by this boundary line here. I've got this section and this section over here. Each of these is called a half plane. So this half plane here is shaded. So we're going to start off by looking at some linear inequalities in two variables and trying to see whether this ordered pair is actually a solution of the inequality. So let's start with 2x plus y is less than -3. We want to know if -1, 9 is a solution for this linear inequality. So for x, I'm putting in the value -1, and for y, I'm putting in 9. And I want to see if that is truly less than -3. So 2 times -1 gives me -2, and -2 plus 9 gives me +7. And so for my final answer here, I have 7 is less than -3. This is not true, which means that ordered pair is not a solution for my inequality. Let's try another one. This time we have x minus 3y is greater than or equal to 8, and we're testing out the ordered pair 2, -2. So for x I'm putting in 2, and for y I'm putting in -2, and I want it all to be greater than or equal to 8. So first I'll multiply, and I get 2 minus -6 here is greater than or equal to 8. This is actually 2 plus 6, which actually equals 8, which actually will work here because 8 is greater than or equal to 8. Well, it's not greater, but it is equal to. So in this case, my point is a solution of this inequality. When we're graphing a linear inequality in two variables, the first thing we have to do is figure out where to put that boundary line, where the boundary line is going to be. If we are using a dashed line for our boundary line, we'll have a less than or a greater than sign. But if we use a solid line, we're saying anything on that line can be a solution. So we're using a solid line for less than or equal to or greater than or equal to. Then we're going to choose a point, something below or above the line to test. That's going to be our test point. And the test point should, like I said, be on the boundary line. And with the test point is a solution for that inequality, we're going to shade the half plane that contains that point. If our test point is not a solution, we're going to shade the opposite half plane. So let's see how this works. So here I'm being asked to graph y is less than or equal to 2 in a coordinate plane. So the first thing I have to find is the boundary line. So I'm just going to act like this has an equals in it. So y equals 2. And I'm going to find that line on my graph. And when I find that line, I'm going to graph it as a solid line because I have the equals to here. So y equals 2 would be this line right here. So it's anything where y equals 2. So 1 comma 2, 2, 2, -3, 2. So anything on that straight line. So I need to come up with a test point. So my favorite test point, if it's not on the line, is 0, 0. So for my test point here, I'm going to use 0, 0. So basically, I'm going to test this point back in my inequality. So my inequality was y is less than or equal to 2. I only have the y variable here, and I'm supposed to sub in 0. So 0 is less than or equal to 2. This is true. So if my test point works as a solution for my inequality, I'm going to shade the area, the half plane, with that test point in it. Everything below this line, including things on that line, since it's a solid line, are solutions for this inequality. So I'm going to shade this entire area. Let's try another one. So I'm going to first graph my boundary line at -x plus 2y is greater than 2. So I'm just going to act like this line has an equal sign here so I can actually find the line. Now this isn't an easy one to graph. I'm going to try to get it in y equals mx plus b form. So the first thing I'm going to do is move the x over to the other side. And I'm going to divide everything by 2, which is going to turn this into half x plus 1. So my y-intercept is at 1, and my slope is 1/2. Up 1 over 2, up 1 over 2, down 1 back 2, down 1 back 2. And this time I'm going to use a dashed line for my boundary line because it doesn't say equals. So I'm going to connect these points, but I'm going to use a dashed line. Anything that is technically on that line is not a solution for this inequality. So I need to find something I can test. Once again, I'm going to pick my favorite test point, 0, 0, because it is not on the line, so I can use it as my test point. So I'm going to go back to my original inequality here, which was -x plus 2y is greater than 2. And I'm going to plug in 0 for x and 0 for y. -0 might as well be 0. 2 times 0 is 0. 0 plus 0 is 0. And is 0 greater than 2? No. So this time, 0, 0 is not a solution. So I'm not going to shade the half plane with 0, 0. I'm actually going to shade the opposite half plane. So everything up here is a solution. I could pick something up here and use it as a test point, and it would actually be a solution to my inequality. All right, we're going to take a look at one more problem here. You can spend at most $10 on grapes and apples for your fruit salad. Grapes are $2.50 a pound, apples are $1 a pound. They want us to write and graph an inequality that represents the amount of grapes and apples we can buy. Then it says identify and interpret two solutions of the inequality. So the first thing I did was I decided that I was going to let X stand for the pounds of grapes I'm going to buy, and Y was going to be my pounds of apples. And then I designed an inequality that would work for this situation. So it's $2.50 times however many pounds of grapes I'm buying, plus $1 for each pound of apples, and I have to spend less than or equal to $10 because it was $10 at most. So the first thing I did was I wrote this with an equal sign here, and I took this equation and put it in y equals mx plus b form by moving the 250 times x to the other side. So I got y equals -250 plus times x plus 10. And I knew that I was going to use a straight line when I graph this, because it did say it could be equals. It's going to be solid, a solid straight line, I should say. And I knew my y-intercept was 10 and my slope was negative 250. So I started with my y-intercept. And then I actually knew that my x-intercept here was going to be 4, because 4 times negative 250 would be negative 10, plus 10 was 0. So I also graphed 4, 0. I connected them. And then I tried a test point, my favorite one, 0, 0. I plugged it in, and I got 0 is less than or equal to 10, which is true. So everything on the 0, 0 side was shaded. Now you'll notice on this graph, I didn't bother to include anything but quadrant 1 because negative values aren't going to make sense here. I'm not going to buy a negative amount of pounds of grapes or negative pounds of apples. So it didn't apply, so I kept it to just quadrant 1, only positive numbers. So what they want us to do with this information is identify and interpret two solutions of the inequality. So I'm looking for something that falls in my solution area. So I could pick 1, 2. So that would be that point right there. It's in the green shaded area. So I identify that as one solution. But I need to identify two solutions. I could also do 2, 5, which is right there on the boundary line, but since my boundary line is solid, things on the line actually count as solutions. So 2, 5. So I've identified two solutions, but now what I'm being asked to do is interpret those solutions. So this one means I'm buying 1 pound of grapes and 2 pounds of apples, and that will be less than or equal to $10. Because it's in the solution set, and I'm only allowed to spend at most $10. So this is one combination of what I could buy for less than or equal to $10. Here's another solution, except this one is saying that I can buy 2 pounds of grapes, and I can buy 5 pounds of apples, and I'm still going to be under my $10 limit. So 2 pounds of grapes and 5 pounds of apples are less than or equal to $10.